Okay, for this question, we would like to find tangent of inverse sine of 5/7. So the first thing we're going to do, remember, this spits out an angle. Inverse sine takes a fraction, spits out an angle. Let's give this angle a name. Let's call it theta. So inverse sine of 5/7 equals theta. That's going to be an angle in quadrant 1. Inverse sine spits out angles in quadrant 1. Here's my angle theta. Let's draw it out. Let's take sine of both sides. I'm allowed to do that. Sine of inverse sine. In this direction, they always just cancel out. Sine and inverse sine are inverse functions in this direction. So I get 5/7 equals sine of theta. What I'm really asking for then, this is important, I named all of this right there. That's an angle. I called that theta. So I'm really asking for tangent of theta. So let's fill in our triangle and find tangent. Sine is opposite over hypotenuse. Let's find the third side. Let's call it A here. So a squared plus 25 should be 49. A squared then will be 24. So A is the square root of 24. And we're asking for, what do we want? What was the question? Tangent of theta. So tangent of theta will be, just use our triangle, opposite over adjacent. And we could stop there, or if we wanted to, we could rationalize that denominator. So the key to these problems, call the inside theta. Take the inverse trig function of both sides, move that sign, that inverse sign over to the other side, so to speak. Remember, that's not multiplied, that's inverse sine of, not times. Get down to an expression that looks like this, draw the triangle, find the thing you're looking for. Okay, let's do another one. Let's do, oh, I don't know, cosine of inverse tangent of 1, or of 10. That's an interesting one. Cosine of inverse tangent of 10. So call this theta. So I'm really asking for, I want cosine of theta. So theta is the inverse tangent of 10. Notice I'm not getting my calculator out for any of this. So in a sense, move the tangent to the other side. You do that by taking the tangent of both sides. So I literally just took tangent of both sides. Over on this side, tangent and inverse tangent, they're inverses. These are inverses. They cancel out. So tangent of this angle I'm considering is 10. My life's going to be a lot easier if I consider that a fraction. Let's make that 10 over 1. Okay, we're in quadrant 1. Inverse tangent spits out angles in quadrants 1 and 4. This is something in quadrant 1 because it's positive. So my angle theta lives in quadrant 1. I know tangent is 10 over 1, but tangent is opposite over hypotenuse, or opposite over adjacent. Let's find the third side, c. C squared will be 100 plus 1, so c squared is 101. C is the square root of 101. We want exact answers here, no calculator. Now finally, what was it I wanted? I wanted cosine of theta. So cosine of this angle theta, notice I never found the angle theta. I don't really care what the angle is. will be opposite or adjacent over hypotenuse 1 over square root of 101. If I want to rationalize that denominator, that would be root 101 over 101. Okay, let's do one with a negative in it. Let's say we wanted tangent of inverse sine of negative 3/5. Okay, so again, everything inside the parentheses, call that theta. Give that a name. So theta is the inverse sine of negative 3/5. Arc sine, inverse sine, only spits out angles in quadrants 1 and 4. Because that's a negative, we know we're in quadrant 4. So here's my angle theta. It lives in quadrant 4. Kind of, in a sense, think of moving the sine to the other side. Take sine of both sides. So sine of theta is negative 3/5. Fill in the triangle. Opposite over hypotenuse. Use Pythagorean to find the third side. You should be able to just do that in your head. This third side's a 3, 4, 5 Pythagorean triplet. I want tangent of theta. Tangent of theta is opposite over adjacent. And we're done.